In today's note, we are going to look at experimental probability. And before we get into it, we're just going to look at some terminology. But probability is the measure of the likelihood or chance that an event will occur. And probability is quantified or shown as a number between 0 and 1, where 0 indicates impossibility, so basically it is impossible for this event to happen, and 1 would indicate certainty, or it's a 100% chance it's going to happen. A trial is any procedure that can be infinitely repeated and has a well-defined set of possible outcomes. And an example of this would be rolling a pair of dice. So we can constantly or infinitely roll a pair of dice, so that event or that action can be repeated infinitely, and it has a well-defined set of possible outcomes. If you have a six-sided die, you only have a certain set of outcomes that you could roll. It's not going to be anything outside of that. An outcome is a possible result of an experiment or a trial. Each possible outcome of a particular experiment is unique, and different outcomes are mutually exclusive. So that means they don't kind of interact. They're exclusive of each other, or only one outcome will occur on each trial of the experiment. So for example, if I roll a pair of dice and I get 6, that is one outcome, and that's the only outcome I can get during that trial. And it's going to be different from some of the other outcomes. An event is a set of outcomes with the same results. So for example, getting heads when you flip a coin is an example of an event. And frequency is the total number of outcomes for an event. So if I flip a coin and I get heads 3 times, the frequency for getting heads in that event is 3. So just thinking, where is probability used, or where have we seen probability? Right, so take some time to think about where have we seen probability, or where have we heard the words chance come up, or the likelihood of something happening. Right, some key ones would be like gambling. Whether it's the lottery or a casino, you hear about the odds of winning are 1 in something, or the chance of winning. In gambling, you kind of think of the odds. Right? So gambling, you hear that in kind of sports statistics. Right? If you're kind of projecting what you think is going to happen, or like you look at save percentage, that means the probability that he's going to make a save, or you have goals per shot. So you're looking at kind of, or any of the statistics, you're looking at basically the chance of something happening, or the likelihood of something happening. Weather forecasts is another one, right? Chance of rain is a percentage. It's also a probability that that's going to happen. So weather forecasts. You could think of census data. So we talked about census before, but we kind of use that, or people use that to kind of project or guess, or come up with the probability that certain things are happening or the way they are. And again, probability is always a value between 0 and 1, or you could think of 0 and 100%, and can be represented as a fraction, decimal, or percent. And experimental probability, the one we're looking at today, is determined using the results of an experiment. So experimental probability is the event, or the probability of what actually happened. Right? So the experiment of what we actually did, we're going to figure out the probability from that. And the formula for that is the probability of an event is equal to the number of successful trials, or number of successful events, over the total number of trials. So the total number of times we did a trial, or did a turn in the experiment. So in example 1, two 6-sided die are rolled 20 times. Doubles were rolled 4 times. Determine the experimental probability of rolling doubles. Express your answer as a fraction, in lowest terms, a decimal, and a percent. So if we want to figure out the probability of doubles, or the probability, and then our event. So our event here is doubles, and basically all this means here is just the probability of rolling doubles. So that's all that refers to, is equal to the number of successful trials. And in this case, because we're looking for the event of doubles, every time we rolled doubles, that was considered a success. And in this case, we rolled it 4 times. And then total number of trials, or the total number of times we rolled the dice, was 20. So our probability is 4 over 20 as a fraction. We want to reduce this to lowest terms, which we can do, divide both numbers by 4, and we end up with 1 over 5, or 1/5, which as a decimal is 0.2. So if you just do 1 divided by 5, you get 0.2. And then to turn that to a percent, you multiply the decimal by 100, and you get 20%. So basically, we could say the probability of rolling, or the experimental probability of rolling doubles, was 1 over 5, or 0.2, or 20%, where there's a 20% chance of rolling doubles. In B, we want to look at the probability of not rolling doubles. So in this case, the event that we're looking for is not doubles. So here we have to think about it a little differently. How many successful events were there? In this case, a success is considered the event we're looking for, which was not rolling doubles. So how many times did we not roll doubles? Well, if we rolled doubles 4 out of 20 times, that means we didn't roll doubles 16 out of 20 times, or just 20 minus 4. We can reduce that to 4 over 5, which as a decimal, 4 divided by 5 is 0.8, or 80%. So that is the probability of not rolling doubles. In example 2, now we're going to be looking at tossing a coin. A coin is tossed 30 times. The experimental probability of turning up heads was 2/5. How many times did the coin turn up heads? And to figure this out, or to figure out the number of heads, we're going to take the probability and multiply that by how many times we did the experiment. So 2 over 5 times 30. Or you could basically think of this as taking a percent, or finding a percent of a number, right? So the probability is our percent, or is this fraction. We're multiplying it by the total number, and we would get 12. So that means, therefore, out of 30 times, there were 12 heads. Or 12% of 30, or sorry, not 12%, 2/5 of 30 is 12. How many times did the coin turn up tails? So the number of tails, you could do this 2 ways. The easiest way is, we know we did 30 trials, and we know out of 30 trials, 12 of them came up heads. So if I do 30 minus 12, I will get 18. So therefore, there were 18 tails. And this is because there's only 2 options when flipping a coin. It's either heads or tails. So if I flip a coin 30 times, 12 of them are heads, that means all the remaining flips were tails. The other way we could do it to figure out number of tails is do something similar to what we did in A, just using a different percent. So the number of tails, the percentage of that would have to be 3 over 5, because again, it's the opposite of what we just looked at. So if 2/5 is heads, then 3/5 would have to be tails. So 3/5 times 30, and we would get 18. So two different ways of solving the question, one using the percent and one using the total number of trials. Example 3, so now we're looking at the results. And we want to know, our results are displayed in a graph. We can see the number of times, if we're rolling a die, we can see the number rolled and the frequency. So we can see this in a bar graph. We want to know how many trials there were. And the way we do this is we just add up the frequency. So 4, 3, 1, 5, 3, and 4. And we just add them up and we get 20. So therefore, because there were 20 results, therefore there were 20 trials. How many times was 5 rolled? So to figure that out, we just look along the bottom to number rolled for 5. I'll highlight that in green. So how many times was 5 rolled? And we look at the frequency, it was 3. So 5 was rolled 3 times. C, find the experimental probability of rolling a 6. So the probability in the event that I'm looking for is a 6. How many times did I get a 6? Well, I got a 6 4 times, so 4 successful trials over 20 total trials equals 1/5 if I reduce it, or 0.2 or 20%. So the probability of rolling a 6 is 1/5 or 0.2, or there's a 20% chance of rolling a 6. In our last example, we're looking for the experimental probability of rolling a 3 or a 5. So to roll a 3 or a 5, I'm going to look at the number of successful events. In this case, I'm going to look at how many times I rolled a 3, which was 1, plus how many times I rolled a 5, which was 3, over the total amount of trials, which was 20. So this reduces to 4 over 20, which equals 1/5, and the same percentages and decimals as above because it's the same fraction. So the experimental probability of rolling a 3 or a 5 is 1/5 or 0.2 or 20%. So again, the main thing from this is just understanding what probability is, how to figure it out or calculate it by doing the number of successful trials divided by the number of total trials, understanding that we can represent it as a fraction, a decimal, or a percent, and being able to use the percent and the total number of trials to figure out how many times an event occurred.